So it's a great pleasure for me to have Dr. Liu here today. So he's an assistant professor of computer science and informatics at University of Indiana, Kokomo. He defended his PhD thesis in 2019 at the New Jersey Institute of Technology, Newark, in the Department of Informatics. He's done interesting work at the intersection of machine learning, detection of fake news, I would say deep learning. So very interesting topic, very modern and current topic. So we're really looking forward to your presentation. Please, Dr. Liu, thanks a lot for being here.
Thank you so much. I'm really appreciated to be invited to give a talk at this event. So the topic of my speak is early detection of fake news on social media. Okay. So this is the outline of my presentation. So first, I would like to introduce a little bit about the background and motivation of the research, and then go over some literature review regarding existing methods, especially detection methods based on machine learning and AI. And then I will also introduce several of my proposed research methods. I conduct those research in the past few years and got some result, got some publications, and finally I will do conduct a little bit of summary of them. So the first important question is, what is fake news? So nowadays we heard fake news very much and very often, but actually fake news can have different definitions based on the context. So so from my literature review, I define fake news as news carrying intentionally and verifiably false information. That means the fake news must be first, it must be a news, and it must contain some false information that is intentionally there, and also can be verified to be false. So for example, we like the gossip is not kind of like a fake news because it is not kind of like intentionally. Sometimes unverified. Sometimes it contains just some unverified information that is not considered as fake news in this context. So this is a widely used definition around the literature. And so why we care about fake news? Because nowadays as a fast development and wide use of and wide coverage of social media. So now fake news has become a very huge issue on social media. So the fast and massive spreading of fake news can cause serious social harms. Fake news can actually affect a lot of things, like from economics to political events. So for example, in 2013, a fake tweet saying that the President Obama was injured in an explosion in White House caused the Dow to plunge over 100 points within 5 minutes. So that caused very big loss on the economics. So this is just by a fake news. And also there are some data shows that fake news are around during like political events like election. So the result can be influenced by that. So nowadays people want to try their best to mitigate the harmfulness of the fake news. So in order to do that, so early detection is crucial. So early detection means early detection of fake news. We don't only want to detect those fake news. We don't only want to distinguish which news are true, which news are false, but we also need to conduct the detection process very early, because if we can only tell if the news is fake or not after a while, since it has been spread over there, then the social harm is already there, is already being caused, and we cannot stop them. So that's the crucial part. But this early detection of fake news is non-trivial and is still a challenging problem because of the several reasons. Mainly, So at least two reasons here. The first reason is that first, manual fact checking is very time consuming. So there are some websites such as Snope.com or like Political Fact. They have their teams, they have their expert teams to investigate on the content of news, and then they do this kind of like manual fact checking. So basically, when a news is reported, and they will investigate on multiple sources and check multiple facts to see if it's a fake news or not. So this process can be very slow. It can like so the usually it takes more than 1 or 2 days. However, we compared with the example we just talked about before, fake news can cause very serious social harm, like within just several minutes when it's usually especially when it's related to economics. So we cannot fully rely on manual fact checking. And also manual fact checking is not scalable because we don't have we cannot have rely on a very big team to manually verify all of the news over there. And also a second category of approach is detection based on machine learning and artificial intelligence. Those are like automatic detection approaches. And the other limitation based on this category is that usually those approaches requires a large amount of data because researchers tend to focus on the accuracy of the model. So they tend to compete their detection accuracy with other existing methods. So in order to do this, they tend to rely on more and more data because usually because from the machine learning perspective of view, so usually if we can have more data, the model will is usually more accurate. So but the problem is that they kind of neglect the importance of early detection. The reason is that in the early stage of news propagation, so for example, within the first 5 minutes, there is usually not enough data. So we cannot have such amount of data to ensure the detection result is to be very accurate. So this is another challenge. So next, I will introduce a summary of literature review of existing AI-based approaches. So this image shows a landscape of AI approaches. So we can actually categorize those approaches based on 2 dimensions. The first one is the methodology part. We have unsupervised method, supervised learning based method, and deep learning. So deep learning are recent models related to recent methods related to especially neural networks. And on the on the bottom axis, it shows another dimension, so which is based on the data we use. So we have actually on social media, we have user data. Besides of the news content itself, so we can have user data, we have the social context data, and we can also get the social network based data. So from these 2 dimensions, we can categorize the existing approaches. So we can group them into the one or more of the grids. And also more and more methods, they tend to rely on multiple kinds of data and multiple approaches. So those are called hybrid detection approaches. So for based on detection models, so we have like supervised based detection approaches such as support vector machine and decision trees. So those are very old and baseline methods. And unsupervised methods includes clustering, topic modeling, those type of approaches. And nowadays, people rely more and more on neural networks. That is the deep learning approach. For example, we have convolutional neural network, recurrent network, and later we have attention network. We have transformer models, the GPT models. Those very big language models can also be used for fake news detection. So this figure shows an overview of overflow of the supervised learning model. So how to use supervised learning to detect fake news? So first we have given the news, so we label the news, we assign the news articles with a binary label. So here it means P and P means positive, N means negative. So in positive means fake news, and negative just means true news or legitimate news. So these are the labels, and then we need to extract certain features from the news. So the features we have talked about before, we can have news content features and non-news content features basically, and then we will feed those labels, those labeled data to a machine learning model M, and then the model will be trained based on the data, and then will be tested on testing data. So then, given the we can in the test stage we can feed a news story A to M, and then the model will determine if it's a fake or legitimate news story. So this is basically the um, overflow of supervised learning approaches. And as for features, the features for detecting fake news have been investigated a lot by by the research community. So basically, we can categorize the features as into two broad categories. The first one is news content features. News content features are features just extracted from the news content, like the article or the paragraph, depends on the length of the news. Thank you. So for example, we can have linguistic features, textual features, and also visual features if the news contains like image or a video. Textual features just the words, the phrases, and linguistic features may be the like um, the syntax tree or something like that. So the problem with the news content features is that the effectiveness is low because the reason is that the people who because fake news are intentionally written to mislead people, so the language they choose is very careful. They just they will not use very they will not use some language that can be easily distinguished as false as or fake. So they try their best to make the language of their fake news looks like true news. So that makes easy to detect fake news only based on the text content. And also another reason is that news are about facts. So for example, we say that today there are some events about like 10 people died somewhere, and they can just change the number to be like 20 people died. So based on language, so how can we distinguish which one is true, which one is false? So this is so only use the news content features is not enough. And so to complement this, so researchers also investigated on social context features. So those includes the like the post-based features, network-based features, and user-based features. Because so the place so on social media we can get a lot of social context features because when the news is posted on social media, people will interact with that. They can like the news, they can share the news to their friends, and they can also reply to the news. So in this case, we can get a lot of social context features. But the limitation of this is that at the early stage of news propagation, that means when the news just starts to propagate, those features are there's also a lack of those features because so for example, users only might retweet a news article without posting any test response. So that means if we want to use their retweet text, sometimes it's not available at the very beginning because there won't be enough retweets. And also if we want to analyze the news propagation network at the beginning, also at the beginning of news propagation, maybe only a few people retweet the news on Twitter. So the propagation network is also not very complex, does not have any complex structure. However, we found that news user-based features are mostly readily available because each user on social media has a user profile. The user profiles are already there, so we can investigate on the user profiles as long as they just they just retweet the news, so we can get the user profiles and get the user features. So this figure shows some example of different features we can get. So for example, this is the news on Twitter. And so we can see this is the username. The username is in the green circle, a green rectangle, and the content features is just the tweet text. So this is in the blue rectangle, and also the network features included in the yellow orange rectangle. We can see how many retweets are there, who retweeted the news, and who likes the news. So these are the uh, news propagation network features. And also the social context feature, the shadow blue rectangle, it shows the time, maybe also the location of these tweets. So this is a very basic example. So the there's a bunch of detailed content, news content features, such as the lexical features. So for example, this table shows a little bit comparison between content features for fake news and real news. So for example, lexical features like you should, real news. So those are usually used in like fake news, for example. And syntactic, some research find that fake news usually use present tense, but real news tend to use past tense more. So those are basically a list of news content features. And we also have some network-based features. So for example, the originality is a metric. So that equals to original tweets versus retweeted for some particular user. So for example, if a user only retweets a lot, but not um, originally, but not post original tweets. So that user may be very likely to be just a robot that automatically post fake news. And also we can also compare the followers versus the number of people following them. And also those measures the influence and credibility of some user on social media. And as for propagation path features, so we have the figure like this. So after a news is starts to spread on Twitter, so this is the source tweet, and we can get a bunch of retweet texts and the users who retweet the news. So this forms a propagation path, or called a retweet path. So we can also use this. This information can also be used to train the model to identify fake news.
Dr. Liu, I have a question. Do you
Uh-huh.
prefer questions at the end, or is it okay also during your presentation?
Oh, sorry, what was your question?
Is it okay asking questions during the presentation, or you
Yeah,
prefer?
yeah, definitely
Yeah.
okay. Yeah.
So I have this question here. So related to these types of features, maybe this is more related to the path features, but is it, for example, the speed at which things propagate? Probably not the most important feature here. Now, why I'm saying that, the reason for which I'm saying that is that now, if independently of whatever true or false information is propagated, right, which is
Yeah, yeah.
very complex thing to determine, as you explained. Could one just simply first have a screening on the speed at which the news propagate? If that speed is, if one has a first screening there, like using that as maybe path feature, that already stops one of the main problems with the propagation of fake news. Because if the amount of fake news, the fake news propagate very slowly, then at a certain point it's just somehow stopped, and the effect of the fake news is basically very limited, right? So is there something like this, like using, having a first screening based on the speed at which the
Speed,
news
okay.
propagates?
Yeah, that's a very good question. Uh, I think some researchers already did that, but I for as far as my knowledge, so the thing is that um so some fake news usually fake news can usually spread slower, but some fake news can spread very fast, like the example I showed. The like the news saying that President Obama is injured. That can spread pretty fast, and our so actually our main focus should be detecting fake news that spread very fast. So because
Right.
if the fake news spread very low, very slowly, we don't need to care about them actually.
Right, right, yeah. So because that seems to me a much simpler feature to compute with respect to because with respect to everything you explained, it seems to me that all of these are very very complicated things to determine.
Yeah,
False or
yeah.
false, true, very complicated.
Mhm.
While the speed is just very not very simple, but much simpler thing to determine. So that's where my question was coming
Yeah.
from. But
So
thank you.
yeah, your point is very good. I have actually did some I actually studied some data on the speed. So actually, sometimes the fake news it's not always spread very slow because they tend to have a team to propagate the fake news. So usually a fake news, if someone wants to spread fake news, um, he or she may not use only one account. There will be multiple accounts, maybe like tens of accounts
Got it.
that post the news at the same time.
Yeah.
Mm. That's a very good point.
Thank you.
Okay. I think that's a very good direction to be investigated in my future research. Mhm.
Okay.
Okay. So this is another, this is some introduction. Oh, okay. So this is the user characteristics. So previous research has found that some users are more likely to trust fake news, and they just because they possess different features, and also those users possess different features from other users. So we can actually so this point inspired me and our team to so that we can probably use the user features to detect fake news. So I will quickly go over that later. Okay. So first I will talk about the analysis of the user characteristics. So basically we want to find out whether the fake news spreaders shares different user characteristics than normal users. So here, user characteristics just means the user features like number of followers, registration age, or a number of tweets, something like that. And so to conduct this study, so we can basically divide the user population into two groups. The first one is fake news spreaders, and another one is fake news ignorance, or just the normal users. Fake news spreaders is the means refers to the users who have retweeted fake news in our collected data set. And we can also distinguish between source users and retweeters. So source users initially post fake news, and retweeters just retweets the fake news, retweets the news. And as for data set, uh, so I and my team use the two public data sets, and so one is from Weibo, one is from Twitter. So Weibo is basically the Chinese version of Twitter in China. So those are the most influential social media sites. And also, so in order to get the user characteristics, the user profiles are crawled using the social media API, such as Twitter API. And this table shows the statistics of data sets. So we can see the number of news articles and the number of retweeters. Number of retweeters is a big number, but number of news are not are a small number because as I mentioned before, it's very time consuming to verify fake news. So this table shows the distribution of different user groups. So we can see the numbers are similar. There is not a bias in those groups. And next, I will show the features being studied. So most of the features are similar in Twitter and Weibo, like the username length, screen name length, and like the friends account, followers account, something like that. And we also have a list of binary features. And then the hypothesis testing conducted here is to compare whether the distribution of user features differs significantly between fake news spreaders and normal users. So for for features carrying continuous values like the number of friends, number of followers, so a z-tests were conducted. So this z-test is a statistical hypothesis testing for continuous data. And for binary features such as whether the user has the geolocation enabled, something like that. So chi-square goodness of fit test was conducted. So this is another test for comparing distribution of binary values or categorical variables. And the result shows that some features has a significantly different distribution. So for example, let's compare so this is a table for source users on Twitter. So we can see that the followers account, highlighted one, the average is for the source user is like 5.4. So this is in log scale. This is in log scale. So the original number is very big. And we can see that for fraudulent source users, so those means fake news spreaders. So the mean is like 5.2, and for normal users, for legitimate source users, the number is 6.3. Since it's in log scale, so the difference is very significant, and z score is pretty slow. It's pretty it's beyond the um significant level very much. So that means the difference is very small. So basically, we found that fake news spreaders tend to have a less followers account because they are not usually followed by a bunch of people. And also another important feature is the registration age. So we found that fake news spreaders tend to have a shorter registration age because they can just be like robots created recently compared with normal users. So these are similar results in other data set. I'm just going to skip them. And for binary values, we can see that has personal URL and is account verified. So those features um, has a most significant difference. That means, for example, for most fake news spreaders, they tend not to have a. Okay, let's see. So okay, so and it's count verified. So we can see most of the fake news spreaders, their account are not verified. So basically, those features also carry a big difference between fake news spreaders and normal users. And we don't need to ensure all of them to have a big difference because when we feed them all in the machine learning models, especially deep learning models, so the model itself can help us do the feature selection and feature combination. So as long as there are some informative features, so we can use that. We can feed them into machine learning model that can help us to determine fake news. So I'm going to quickly skip this. Okay. So next, I'm going to introduce the deep learning models that I proposed in the past few years. So the first
Dr.
one.
Liu,
Oh,
can I ask you another question? So
mhm.
it's related to, so did you mix the two data sets or did you study two data sets independently?
Independently.
Good. So because then there is the transfer learning problem, right? Because you want to transfer the information from the Twitter distribution with the
Uh-huh.
Weibo distribution, and then because those are two different populations, but it would be interesting to know what information can be moved from one population to the other. Especially because it seems to me there is a little bit of discrepancy in the amount of, so it seems to me there is kind of different distributions, right?
Yeah.
Yeah.
Different.
That seemed to me that there might be an interesting question there. How do I transfer the information from the Weibo population to the Twitter population? Even
Yeah,
considering that
that's a
there are
very
some
good point.
different,
Yeah.
yeah.
Yeah,
Thank you.
I totally agree that that's a very good point. So I'm actually continuing research on that direction also, because the Weibo is in China for Chinese peoples and
Right.
Twitter is for American people, so they have some different distributions. And also another more general problem is that the distribution of the user feature change with time is itself. So for example, on Twitter, so those features from like 10 years ago are different from nowadays, right? So so the problem, yeah, that's very good. So how to do transfer learning. So how can we make use of the previously trained model? So for example, to predict fake news about like COVID happened recently.
Right.
So that's also a very big problem because I think that is also not addressed enough by existing researchers because for example, they trained the model like 5 years ago. So the distribution of user features are no longer the same as nowadays. So
Right.
how the model can be used to detect fake news about like COVID happening recently. So I think that's a big question.
Awesome. Thank you. Thank you.
Okay. So next, I will briefly introduce some of my proposed models. The first one is called propagation path classification. So basically, in this model, I incorporated the RNN and CNN. So basically, recurrent neural network units and convolutional neural network units to perform to perform detection based on the propagation path. So this figure shows the basic architecture. So basically, after a news is posted on Twitter, so we can get a sequence of retweeters. So this forms the retweet path, and then for each user from each nodes in the retweet path, so we can extract the user features, and then we can represent each user as just a vector of user features. So the user feature vector will for the entire propagation path will be a 2D, will kind of like a 2D array. It's kind of like an image. So the first dimension is the propagation sequence, and another dimension is just the feature. And then, so we can adopt some neural network modules for like for image data. Like we have RNN, CNN, and maybe also we have the transformer model later. So we can combine them together to extract intermediate features and then merge them together, and finally feed the intermediate feature to just to a classification module, and then the final result will be a binary label that indicates the truthfulness of the news. So this is basically the model's architecture. And these are the data sets. And these are a bunch of baseline modules proposed in the past few years. And this is the module configuration. And for early detection, I proposed an concept, so which is called a detection deadline. A detection deadline is a time point when our model make prediction based on the current data. So, for example, if we set a detection deadline to be 1 day, then the model should not access to the data that is later than 1 day after the news was posted. So this is the detection deadline can be used to trim the data and measure the early detection performance. So these are the evaluation metrics basically. So this is the optimal performance. So we can see the optimal performance accuracy is like 80% something for my first model. And the interesting part is as for the early detection. So we can see that the green lines are my proposed methods, and those are other lines are baseline models. So we can see uh, my proposed method, the performance is become stable all the way down because the detection deadline is measured by hours. So this is because our model can detect fake news in just a few minutes. We don't need so many hours. So the performance already reached to the already saturates. And then if we compare these two figures, we can see it's more significant. So for example, on the left side shows the speed of news propagation. So basically the news this is speed. So we can see how many in how many minutes after we can get how many retweets. So on the right side, the three line means the three data sets. On the right side, it shows the relationship between the number of retweets and the accuracy. So we can see that basically in our model, we only need like 50 retweets to reach the highest accuracy. So if the fake news spread very fast, it takes very short time to get 50 retweets. For example, like 5 to 10 minutes. So we don't need to wait a couple of days to deliver the result. So this is the big advantage of this model. And okay, let me just skip this one and directly show the last model. Okay, so this is the model I just introduced was published in a triple AI conference in like I think it's in 3 years ago. And this model is a revised model, and it was published in ACM transactions on information systems. So basically, this is the model based on the something called I call status sensitive crowd response. Compared with the previous model, we also combine the user's text, retweet text, with their user feature. So this is called status sensitive crowd response because the crowd response means the user's response. So we call it status sensitive because it's sensitive to the status. So that is the current status of the user. So which is basically the user feature at some time point. And then so this is how to construct the status sensitive crowd response. So basically these are the retweet text, and we can extract some texture feature, and then we can also extract some user feature from the user profile and combine them together. So you see, so we can extract some text feature based on text CNN, and later we also adopted the language models and the transformer models, and also we can extract use some encoder to autoencoder to extract user features. Finally, we combine them together. So this will be the status sensitive crowd response feature. And then so this is the model. So I use the attention network based on the and also the position aware attention network. So it's kind of like a similar idea as transformer model. So we just take care of the position of each retweets. So for example, whether it's the first one, it's the first 5 or something like that, and then use the convolution network to extract some intermediate feature and finally get the class label. Those are some of the formulas. And also, I also proposed the PU learning framework. So PU learning? It means learning from only positive and unlabeled examples. So why PU learning is suitable for fake news detection? Because in real world, unlabeled news is much more than labeled fake news. So we can get so for example, we can start from like a couple of hundreds of labeled fake news, and then we can collect a huge number of unlabeled news. We don't know whether they are true or false because we don't have the manual power to evaluate them. And then so we can use a pure learning framework. So basically, it's a repeated program, iterated program, iterated procedure. So each time we basically we can assume that most of the unlabeled news are true, and then each time we randomly select some pseudo true news and then combine with the labeled fake news to make a balanced data set. So we can use this test data set to sample the data set to train a weak classifier. And then we can repeat the process over and over again. And then a bunch of weak classifiers will be trained. And then we ensemble them together based on some policy. And then so that we will get a strong classifier. And then we will go back, we use a strong classifier to classify the unlabeled news. And we pick some of the top ranked fake news and injected them into the fake news dataset, labeled fake news dataset. Then the dataset, labeled dataset becomes larger. So this solves the problem of the limited data, that is a limited number of labeled fake news, and also the class imbalance problem. So this is the PU learning framework. Okay, so this is the result. You can see that this is a training. The training performance is roughly the same as the validation loss curve. So there's no overfitting. Those are the several of the results. We can also see that the number of as the number of retweets goes down. So that means from 10 to 50. That's the early stage. So our proposed method beats the state of the art method more significantly. Okay, so they just skip off this. So finally, I will talk about some discussions limitations. So for example, I think the most limitation is the size of the fake news. Volume of fake news is very small. And to solve that, there are some recently people propose some large data set. So which one is called fake news net. However, fake news net is only relatively large, but the absolute amount of fake news is still cannot be considered as large in the context of big data. So this is because of the nature of fake news. It takes very long time to verify the fake news. And also we have some missing user profile problem because some like malicious user, their account may be suspended by Twitter. So if researchers do not collaborate with the Twitter company, so we cannot get their data. And so okay, so I'm going to skip these discussions. So basically, another problem is that another problem we found later is the distribution of user features varies with time. So that can make many model useless. So for example, if you train a machine learning model based on user features this year, can it be used next year? Because next year the user feature change because the users will be there and for example, their number of followers keeps going up and up every year. So that is a problem. And also even for content features, the fake news topics is always dynamic. So for example, now in the past few years we have like the COVID, and actually the topics of COVID also varies with time. So those are limitations. So those limitations prevents the decrease the generability of some model, machine learning model developed in lab um, conditions. And finally, I would like to just talk about a little bit my future research undergoing. So now I'm incorporating the language models, neural language models such as GPT model and the transform model to and also consider the time of each post to distinguish between the context of each of the news article in a particular time. So for example, during the period of pandemic, so we have the topics are constantly changing. So for example, I think it's 2021, so we have like Omicron, the terminology Omicron keeps increasing. So that makes the modeling of the language modeling to be a little bit different, and it also influenced the fake news detection. Okay, I think these are my major topics. Okay, thank you again for inviting me. Okay,
Cool.
so do you have any question?
Thank you very much for your very interesting presentation. Our pleasure. Thank you for being here. So, questions. Let's start with the online audience. Anybody? That's some. So.
Okay, thank you.
Oh, yeah. Well, I'll ask him one more question. Okay, myself,
Okay.
and we'll see if
I appreciate it.
someone else. So, um, so about the problem of distribution shift, okay?
I see.
So other than the fact that it's just a super hot topic right now. So there is Saturday a workshop at Nurix, okay, about distribution shift, right? But what I'm trying to understand there is, Okay, so two questions. One is this one. So how complicated it is? Because I mean, with even if your data set is still relatively good, but how representative it is for what concerns the problem of distribution shift. Like things change over time, as you mentioned, right?
Yeah.
So I find it very, very complicated for any, there should be some sort of automated way to retrain the model every amount of time. Let's say every month. I don't know, every.
Oh, I see.
Right.
Return.
So then, because otherwise it's going to be very complicated to, try to detect what is the distribution shift and take care of that on, a rolling basis, right? So how do you address that?
So you mean how to address the
Yes, the problem of the change in the population, right, with time, right? It seems very complicated.
that is hard because
Yeah.
we need to propose some like methods to do the normalization because normalization is very important. So if the population changes and their features changes, so it's very hard to find a kind of some basis to do the feature normalization. Yeah, because in machine learning we need to in like neural networks most of the time we need to convert data into scale from 0 to 1. So we need to have a good way to normalize the data.
Awesome.
Mm.
Other questions? Yes.
Should I go up there? Can you hear me?
Sure. Feel free to come in. Yeah. Yes, we're on one question.
Okay.
Yeah.
I had a question regarding Twitter verification specifically, because I believe this data set that you're working on is from 2015. With the
Yeah.
current changes, or I believe you did say that you were using that as a predictor for your modeling, right?
Yeah.
How do you think the current changes going on in Twitter will affect the validation process with that in regards to the fact that now like Twitter's allowing people to pay to be verified rather than doing the verification process themselves? Do you think it would still like have an impact on the modeling, or do you think it's a completely different thing where it can't be used anymore?
Good.
Okay, that's a very good question. So you mean okay, so that I want to clarify this. So you mean a verification is for like a verification for users?
Yes, Twitter verification, yeah, like the blue check mark. Is that what you're talking about?
Yeah, I got your idea, but okay. However, I do not have enough knowledge about the user verification because my focus is on fake news. But as you the point, I think the point can be similar because um so as the time goes on, more people maybe pay to verify their account, or just like also their features can change, especially the number of followers. The number of followers always changes, always goes up. They cannot decrease. That caused some features to have different distribution over time. So which is not easy for a machine learning model to do automatic verification.
Awesome. Follow-up questions? Good. Anybody from the online participants? Well, before closing the session, so I would recommend everybody to come back tomorrow. There are going to be other very interesting talks and other events Thursday, in particular the Data Hub Club event and other interesting presentation. So, is there any last minute question? Well, if not, really, thanks a lot for the great presentation. It was very
Okay, thank you again.
Thank you very much for
the
your
audience and your questions.
Thank you. Thank you very much. Thank you.
Have a good day.
Thanks a lot to the participants too.